Hi everyone, thank you for having me. I'm Anukriti, and this paper is joint work with Sonia Bhalotra, who's at University of Essex, and Hugh Tam, who is a postdoc at University of Oxford. So we are all economists, but I'm very pleased to get feedback from demographers because this is a paper essentially about demography. So there's a large literature which shows that when birth control technology experiences technical innovation, so for example through either birth control pill being introduced or even through abortion legislation, then that can have a lot of socioeconomic impact. So there is previous research, so I've cited some of them here, which shows that when women get greater control of their fertility, it impacts their marriage market outcomes, it also impacts their labor market choices and even the investments they put in education. And it also has impact on their children. In fact, there's research which shows that if parents have children that they really want, they tend to invest more in their well-being. So this is sort of the broad setup in which this paper is placed. But we are going to look at another form of birth control technology, which is basically using ultrasound scanners for sex selecting your children. So, and how does that technology impact quantity and quality of children in India? So why is ultrasound scanner a birth control technology? Because if you look at countries where parents prefer sons over daughters, or at least have a desire for having a certain number of sons, what it leads to is you basically have an ultrasound and then detect the sex of the fetus, and if you learn that you're going to have a girl, then you basically perform an abortion. So this is what we call sex selective abortions, and in that sense it's a birth control technology. So this, the access to ultrasound scanners in India and China, for example, has led to a huge change in the demographic setup. And this is a very reliable technology in the sense that you can detect the sex of the fetus as early as 12 weeks of gestation. So before this, you could only use amniocentesis, which you could only use a little later. And it also is quite low cost. So in India, for example, for 1,000 rupees, which is, so $1 is 60 rupees. So it's not very expensive. You can actually get an ultrasound as well as an abortion. So it's pretty cheap, and it's also not very invasive. Of course, if a mother has repeated abortions, then that may have an impact on her health. But other than that, just say one episode of abortion, if it is practiced in safe circumstances, does not typically have any sort of health impacts. So this was not always the case. This technology became available in early 1980s. And since then, there's research, and there's a paper which I cite here by one of my co-authors, which has shown that approximately 6% of all potential female births have been aborted in India during this period of 95 to 2005. And if you look at this as an absolute number of girls, it's huge, right? So it's, I think, 1/3 of all girls that are born in the US each year. So it's substantial. Also keep in mind that it is not illegal to get an abortion in India. So since 1972, abortion is legal. However, given that this technology is being used for sex-selective abortions, since 1996, it's illegal to obtain a sex-selective abortion. So you cannot go get an abortion just because you're having a girl. But as you can make out, it's very hard to sort of have both of these policies being implemented at the same time. So this law basically, people know that it's there, but it's pretty easy to evade it. So there, for example, you'll hear things like, if you getting an ultrasound is obviously not illegal, so you can go get an ultrasound, and the provider is going to come and say, oh, congratulations, which would be a code word for that you're having a boy. Right? So people find ways to sort of convey this. So the total number of sex-selective abortions has gone up, which it was 0 because you couldn't detect the sex of the fetus until this technology came about, and to about 1.6 million per year in 2005. So this is sort of a huge trend in the demography of these countries. So this is a graph that just shows you the trends in the supply of these ultrasound scanners. So initially, India did not have domestic production of ultrasound machines. Most of it was imported, and imports also sort of began when India liberalized its external trade sector. So this began in like sort of around 1981, but then picked up momentum in early 90s. So this is when India liberalized its economy, and so you can see that here sort of. So I have data from 85 to 2006. The dashed line here shows you the number of imported ultrasound machines. So that sort of went up during this time period, and correspondingly what we show is that, so it's given that it's illegal to have a sex-selective abortion, it's very hard to collect data on it, right? So you ask mothers, DHS asks mothers, have you had a sex-selective abortion, or they'll ask, have you had an abortion, but those things are probably underreported. So what we do know is when mothers are asked whether they have used ultrasound at any point during their pregnancy, we have that data. So what we do is we look at the fraction of births for which mothers reported using an ultrasound test at some point. And these are children that are actually born and not aborted, right? So this is definitely an underestimate. But what you see is that even that sort of follows a similar trajectory. So it's obviously not perfect, but it shows you that the increase happened when there was an increase in the supply of ultrasound machines. This was just imports. So in this next graph, we show you the domestic production. So again, around before 1990s, there was very little that was produced domestically, and then over time it went up substantially. And if you compare the magnitudes, here say in 2003, you see about 20,000 machines being produced. Imports are much, much smaller relatively, right? So bulk of these machines are now produced domestically. Okay, so this is just simply showing you that there was an increase in the supply of ultrasound machines, which seems to be correlated with the usage of ultrasound machines. But that doesn't tell us whether they are being used for sex-selective abortion. So this is another way to sort of look at the data and try to reduce it. So on the x-axis, we have plotted the same thing, fraction of births for which the mother reports using ultrasound at some point. And then on the y-axis, we are showing whatever data we have from a number of sources on number of abortions taking place per live birth in a particular state. And what you see is that these are sort of quite strongly correlated. So if mothers report using ultrasound at a greater rate during pregnancy, those are also the states and years during which more abortions take place typically, right? So there seems to be some correlation.
Are these years?
So these are state year observations.
Okay.
Is an ultrasound covered by health insurance?
There's really no health insurance in India. So there's, if you are employed, then maybe your private sector employer might provide one, but it's not. Okay, so so this was all just the setup. Now let's sort of try to see what that means for effects on, say, postnatal outcomes. So let's say there's no ultrasound technology. You cannot detect the sex of the fetus, but you still have some preference, right? So you may want a certain number of sons. Or you may actually dislike daughters because you have a budget constraint. You can spend your income either on your son or on your daughter, so you may be able to spend less on your daughter. So you discriminate. So if people did not have access to ultrasound and they have this subjective desire for sons or neglect what they would like to, for example, not invest in daughters, postnatally what they could do is maybe commit female infanticide. So this used to be quite prevalent if you go back like 100 years ago. In several parts of India, or if you don't want to do that extreme behavior, you could maybe selectively neglect your daughter. So there's evidence that when a daughter is sick, she's much less likely to be taken to a hospital than if a son is sick. Or she will be taken to the hospital only when she's really, really sick, whereas the son may be taken much sooner. Right? So if you have this sort of intra-household gender discrimination in allocation of resources or care, then what you would see is that that could also lead to greater mortality for girls relative to boys. Right? So that's another mechanism. A third source of, say, excess female mortality might be son-bias stopping rules. So son-bias stopping rules are simply that you keep having children until you've had your desired number of sons. Yeah.
That intra-household allocation of resources, does that include dowries?
So this is simply when you're a kid, do you invest more in a son versus a daughter? Why parents do it could be related to dowry, for example. So I have this other paper, a new paper, which tries to see if dowry implies differential investments in children, and we actually don't see much in that dimension, but what we see is that parents save more when they have a daughter relative to a son for the dowry, but they try to finance it by increasing earnings, by working more, and not simply by reducing consumption in the daughter, at least so far. Yeah. So there could be many reasons why parents do this, and dowry, for example, has been suggested. So apart from these two things, the third thing parents have done is have son-bias stopping rules. So, but if you practice son-bias stopping rules, what it means is that typically girls will be born in larger families. So you will see a pattern of girls, 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 a boy, and people stop having children, right? So an average girl is then born in a larger family than an average boy in a particular region. And when this happens, even if parents don't discriminate between their children, so if I have a girl and a boy, I may not discriminate amongst them. But just because girls are born in larger families, per capita resources available to a girl on average are then smaller. And then that can be another reason for why you see differential, you see gender gaps basically. So this is when you do not have access to sex selection, and then you basically, manifestation of gender discrimination is through these methods. So what happens once you actually can eliminate unwanted daughters? So our hypothesis is that access to prenatal sex selection reduces the need for postnatal discrimination, right? So now if you don't want to have female infanticide or reduce or have neglect or follow sun-biased stopping rules, you simply do not have the girls that you can abort. And so basically what we want to test is it the case that when you have prenatal sex selection, it reduces postnatal gender gaps because all the unwanted daughters are basically eliminated before birth. Okay? And so in fact this is what we find. So we look at this in 3 dimensions. We look at whether there is changes in excess girl mortality. So this is the difference between the mortality of girls and boys. Whether there is a change in gender gaps in health investments, and whether there's this change in sun-biased fertility. And what we find is that in all 3 dimensions, there's a huge decrease, a substantial, in fact, decrease in the gender gaps postnatally. Yes? So that's sort of the main result of the paper.
Now you're free. You have the last 15 minutes.
Yes, exactly. 15 minutes? I have more time to think. Okay, so how do we do this, right? So this is, so we use 3 different types of variation. So firstly, we're going to always compare girls with boys, right? So even boys may benefit from a lot of different things, but we're always going to look at the gender gap. So that's the first use of variation. The second thing, which is obviously necessary, is we want to look at the impact of prenatal sex selection, and that is being driven by access to ultrasound technology, so we need to somehow introduce variation in ultrasound access. So we do this basically through, in a very crude way. There's very limited data in India on actual number of machines you have in each region, for example, over time. So what we do is simply look at the time variation in access. So we know from a lot of anecdotal sources as well as previous work by one of my co-authors that the first change in the supply of ultrasounds took place around 1985. That's when the imports, for example, started coming in. And the second break took place in 1995 when domestic production started. So we simply create these 2 dummy variables. One is, were you born, or whether we are looking at a pre-1985 time period versus between 1985 and 1995 and versus post-1985. So we split our sample into these 3 time periods and we look at those. But just because you have access to sex selection technology, it doesn't mean you're going to use it, right? So even if there is an ultrasound scanner next to my house, doesn't mean I have to go use it. So I have to have so we want to look at people who actually have an incentive to commit sex selective abortion. So there's a lot of literature which shows that one such source of variation is looking at the gender of the first child. So typically, people whose first child sex ratio, if you look at it in India, and I'll show you results on that, it's still pretty random, right? So whatever you expect naturally, which is about 51% of the births should be male, that's what you see in the data. So people still do not commit sex selective abortions for first child, and one reason could be that they may want more than 2 children. And typically, parents don't dislike having daughters, it's just that they really want to have a son. So if they want more than 2 children, they're okay with seeing what the first child is naturally and then start doing sex selective abortions later.
Wouldn't we expect rational parents to also, it may be much less at the first birth, but it would still be, there's some cost to having a daughter. It means that.
So this tells us that it's not always the case that parents at every birth do not want daughters. So in fact, there's a paper by Seema Jayachandran. What it shows is that if you ask parents if you could have only 1 child, what would you want it to be? They say a son. But said if you could have only 2 children, they prefer to have a boy and a girl as opposed to 2 boys, right?
But if I want to have at least 1 boy, then there's some cost to giving up a chance on the first child.
Yeah, but if you know that you can have sex selective abortions, you can definitely ensure that you will not have a daughter either, right? Or the cost of actually eliminating a daughter is not so small. And remember that girls actually are not useless in some sense. Like parents want a girl because they are the ones who actually participate in household work. They are the ones who actually take care of the parents when they're older, even though technically they don't stay with them. So it's not that parents dislike girls in the sense they don't want any girls. It's just that they also want a boy. And so the margin at which they sort of practice that desire is not at first birth.
Is it possibly the case that if they're going to have a boy and a girl, they want the girl to be first?
So that we don't know. So people haven't collected data on. Yeah, it's hard to. So in fact, let me just show you here. So this is what sex ratio looks like in India. So this is for different birth parities. So the first graph here is just looking at first birth, and this is the percentage of births that are female. And these 2 vertical lines are just those time periods that I was just describing. And what you see is that there is really no increase in sex selective abortions at first birth, right? So it's pretty flat. But if you you now look at second births, and then this is third births and fourth births, if we now split people by whether their first child is a boy or a girl and look at the likelihood that the second birth is a girl, if your first child is a boy, there is again nothing going on in the second child sex ratio. But if your first child is a girl, after ultrasound became available, you see that the likelihood that your second child is a girl starts decreasing, right? And substantially.
This is for all of India.
This is for all of India. This is just average. Yeah.
So is this, just to give us some background, is this something that almost everybody agrees on? Like the extent to which a son is, like for Muslims or Sikhs or?
So there is variation. So for example, Northwest India has much stronger, or you'll see this pattern much stronger in Northwest India as opposed to Southern India or Eastern India. Upper caste groups, wealthier groups, more educated groups tend to show this more. So some of it could be driven by the fact that they have a stronger self preference, or maybe they just are wealthier, so have access to technology easier. Yeah. But there is heterogeneity. Yeah. But this is national average, all of this. And the same is true if you look at third births. So again, these are parents whose, so here the red line is basically if you have a boy, and this is when you don't have a boy. And again, you start seeing that once you have, if your first child is a boy, then you don't really need to do this. But if your first child is a girl, or even if your second child is not a girl, you basically are more and more likely to practice sex-selective abortion, the higher the birth parity and the fewer the number of boys that you have, right? So the incentive to use the technology is not just dependent on whether it's available or not, but conditional on availability. It varies by whether you have a boy or a girl, and we use as the sex of the first birth as that source of variation. It's also important for this identification strategy to work that firstborn boy and firstborn girl families should be similar to each other in all other respects, right? All we are saying is that randomly one family ended up having a boy and therefore then were less likely to practice sex-selective abortion, and then another family randomly had a girl for the first child and then they were more likely to practice. So we do show in the paper, and I'll show you a table, is that there is no other socioeconomic differences between families whose first child happens to be a boy and families whose first child happens to be a girl, right? Because if this was actually manipulated, we should see some variation exactly as what I just described to you for India in general. Okay? So these are the three sources of variation. We use data from the DHS of India, so this is called the National Family Health Survey, so we use 3 rounds of it. And this is a repeated cross-section. I'm sure you're all familiar with DHS, and it's a pretty large sample. So we have more than 500,000 births for more than 200,000 mothers for the period of 1973 to 2005. So as you can see, this has a lot of years before ultrasound became available, so 73 to 85, and then we also have a lot of post-ultrasound years. In addition, we use this other data set which is known as Rural Economic and Demographic Survey of India. So this is, as it says, only a rural sample. But the good thing about this survey is that it tells us health investment data for all children that a family has when they are surveyed. The drawback of DHS is that it only asks for things like breastfeeding, immunization for maybe just the last 2 births or the last child. And so this doesn't give us a long enough time period on which we can actually analyze. So that's why we supplement it with this data set. So I've already shown you this. There's variation by child's firstborn sex. This is the table which shows that there's balance based on first child sex ratio. So here, basically, if you focus on the last column, it's looking at the difference between the average socioeconomic status variable for firstborn boy and firstborn girl families, and if there's a star, it means it's significantly different. Basically, along a lot of dimensions like plurality, your religion, your caste, mother's education, father's education, mother's age at birth, her birth cohort, and household wealth, there are really no significant differences between families whose first child is a boy versus a girl. So this again shows us that first child sex is more or less standard in this setting. Okay? But we still control for all these things when we run our regressions. So the identifying assumption for us to do this triple difference in difference estimation is that in the absence of ultrasound technology, the trends between the gender gaps among firstborn boy and firstborn girl families would have remained the same if there was no ultrasound, right? So we're not saying that there is no gender gap in firstborn boy families. If maybe parents have some subjective dislike for girls, irrespective of whether I have a boy or not in my first child, I will still invest less in my daughter, right? But what we're looking at is the differences in the gender gaps of these 2 types of families that comes from the fact that one of them has had a boy and one of them has not had a boy. Okay, so we're comparing that difference.
So, sorry, this is still not clear to me.
Mm-hmm.
So the outcome is you're comparing, say, 2 families with 3 children, and you're looking at the health investments in the 3rd child or something like that?
So we're looking at health investments in all second and higher order children.
Okay, so 2 families with 2 children, we're looking at the
The second-
investments in the 2nd child. One family has a
Boy,
first child is a boy, one child has
Has a
girl. Then we control for the sex of the 2nd child, and then we compare that situation before and after the ultrasound?
yes, yeah, exactly. So it could be that even and in some specifications, I'll show you, we also have mother fixed effect. So what we do is for the same mother, we can compare how much the gender gap between her second and higher order children is before versus after ultrasound technology.
So the thing I'm thinking about is that the family size is going to be related to all kinds of characteristics. They're going to be related to the trends in all of your outcomes.
Yes, so you will hold on for a
Okay.
slide and then I'll show you the specification.
Okay.
So we try to control for all these things. Right. So this is simply a graph that shows that this identification assumption sort of looks alright. So this is the difference between the trends of firstborn boy and firstborn girl families, the gender gaps in mortality. This is under 5 excess female mortality before ultrasound. So it doesn't look like that there was any increase. So for example, if it was the case that firstborn girl families were anyway expecting a decrease in their gender gaps irrespective of ultrasound, then we should see that this should have been negative, right? So this is, yeah.
I'm sorry. When the ultrasound becomes available, is that just purely a matter of the technology being developed, or was there economic liberalization or something like that?
So there is economic liberalization which led to the imports, for example, so
Yeah.
in terms of the entire country. And it was also the case that it first, so people were first supplying it to regions of the country where you think it might be more useful, right? So it is true that ultrasound was more likely to come in say maybe northwest India as opposed to south of India. But essentially, as I'll show you in my identification, we are going to compare even in that small region, firstborn boy versus firstborn girl families, right? Yeah. Okay, so this is just again a robustness check. So what we show here is that the sex of the first child is not affected after ultrasound technology became available, because if that also did, then our instrument sort of is not valid. So that didn't happen. So this is simply showing you the result in terms of summary statistics. So here, these are the percentage of children who die before age 5 in India. By their gender, so this is male children and female children, and by the sex of their oldest sibling, right? So this is only looking at second and higher parity children's mortality, under 5 mortality. So if you are born in a family where the first child was a boy, boys, for example, before ultrasound had a 12.9% chance of dying before age 50, right? So it's not low even for boys, because India is a poor country, relatively access to health facilities is not very strong. And this is for females, so again, the difference was not very high, right, between boys and girls. But if you were born in a family where the first child is a girl, the excess female mortality was just much, much higher, right? So this is what the underlying story is. And then after you look at this early diffusion period, which we say when most of the ultrasound was coming from imports, and this late diffusion period when you had domestic production, you see that actually decreases substantially, right? So this is sort of what our result is, and there is not much is going on here.
What birth order are the children in the far right columns?
In all of these are second and higher parity birth order children. So not first child, but everyone else. Okay, because first child sex we are just taking as here as the source of variation. Okay, so there was gender gap in excess female mortality, primarily in children in firstborn girl families, and that's what decreased after ultrasound technology. Okay, so how do we estimate it in a regression? So looks complicated, but it's basically the same thing that I have just been describing. So here the outcome would be a dummy variable for whether a child I who is of a birth order B, born to say a mother J in year T in state S, dies before age 5. We also look at neonatal mortality, right? So this could be neonatal mortality as well. And then we see whether we regress it on this triple difference. So this is simply the interaction between the child gender, so whether the child is a boy or a girl, whether the the oldest sibling of that child is a boy or a girl, so this is the firstborn girl-boy dummy, and then whether the child was born before or after ultrasound became available, right? And then we have these 2 terms because we are dividing the post-ultrasound period into 2 time periods. Okay. Now, all these other things that you may be worried about are going on. We try to control for them here. So one, we have all the double interactions and then the mean effects. But what are they capturing? So for example, let's say this term state here fixed effects. So this is capturing any change in the gender gaps in mortality, or even male or female mortality, that are simply happening over time. So in India, mortality is going down over time for both boys and girls, right? Because India is becoming richer and people are getting more educated. And these trends are also different across states. Some states are just developing at a much faster rate. So those sort of source of variation is being captured here, right? Similarly, if say son preference is also decreasing over time, let's say, because people are becoming modernized, and maybe that is also happening at a differential rate in some states, those sort of things are also being captured here, right? Similarly, what are, let's say this is birth order year fixed effect, right? So maybe children of birth order 2, because family sizes are decreasing for everyone, are somehow doing better over time because family sizes are decreasing over time, right? So those things are also being captured here. Similarly, things that vary by firstborn sex or the child gender, everything is being controlled for here in all these different ways, right? So anything that does not vary by time, first child's sex and your own sex is being captured here. Okay, so all these omitted variables. We control for all these socioeconomic characteristics that I just described previously. We have all those things here in our controls. And so we are simply looking at this triple difference as our source of, as our causal impact, basically. Standard errors are clustered by state. So the control group in some sense is all the children that were born before ultrasound. After ultrasound, we are looking at only the difference between all children in firstborn girl families relative to firstborn boy families, right? So the control group also comprises second and higher parity births to mothers whose first child is a boy. Okay? Alright. And as I said, in some specifications, because a mother has more than one child in our data, and we have for each year during our survey, during this time period, we know whether the mother gave a birth or not, we can have a mother's fixed effect specification. So we look at the same mother's children, look at the gender gaps between her children before ultrasound and after ultrasound, and see whether that is different for mothers whose first child is a boy versus a girl. Okay? Any questions so far? Okay. I know it's a bit too much. Okay, so this is the first result for mortality before age 5. So we are looking again at excess female mortality. So this is difference in mortality for children of birth order 2 and above. Okay. So I'm just showing you 3 coefficients. They are all specifications basically become stricter as we go from left to right, and this is the mother fixed effect specification. But in all cases, what you see is, first of all, this is the interaction between firstborn girl and female. So this is telling you, before ultrasound became available, in firstborn girl families, were girls more or less likely to die than boys? And what you see is there was a significantly higher chance of a girl dying before age 5 than a boy in firstborn girl families before ultrasound. After ultrasound, that decreases. So this is negative and significant here, right? So the excess female mortality decreased after ultrasound in firstborn girl families relative to firstborn boy families. And if you look at, just compare the sum of these 2 coefficients with this, it basically tells you that most of this excess female mortality that you saw before in firstborn boy girl families relative to firstborn boy families actually goes away. Okay, so
The stars here are comparing with 0, or they're comparing with the previous row?
with 0.
But the interpretation is we want to compare to the first row, is that right?
So this is telling you, so we can compare them now with the first row, right? So we can look at, this is a significant decrease here, this is a significant decrease here, and this was the actual total EFM before ultrasound.
But we can't, the post 1 and post 2 are discrete time periods, so
Yeah.
we can't actually add them together and
You
say
can't.
they eat up the whole difference.
So what we do is, therefore, we basically forget about post 1 and post 2 and simply look at post ultrasound, right? And just see whether that actually, how does that compare with the previous one? And so here you actually see there's about a 60% decrease in excess female mortality. Again, this is not saying that there's no excess female mortality in India. This is simply looking at excess female mortality in firstborn girl families relative to firstborn boy families. So even firstborn boy families may have excess mortality because of other reasons. But this is coming from the fact that these people do not have excess female mortality due to the fact that they wanted to have a son. Yeah.
These differences by sex are additive or multiplicative in mortality?
In what sense? Sorry.
Well,
in terms of my
This is
coefficient.
Do you
minus
just subtract, is
1.7%.
it just the difference between mortality rate for boys and for girls, or is it a ratio or difference in
So
logs or something like that? That is it going to be affected by a big decline in overall mortality rates and by perhaps, with sex-selective abortion, the completed family size is going down, so per capita
So it
income is
could be
going
all of
up,
them.
and
It
blah,
could be
blah, blah.
It could be all of them, because here when we run this regression, this y is just the mortality, right? So we're not taking a difference in y. So we have different observations for a girl as well as a boy, right? So we simply do the interaction here, but this is a difference in the additive sense and not multiplicative sense, because like a regular differences and differences
So
estimation.
it might be interesting to do it by multiplicative and see if it makes any difference.
Yeah,
I don't
yeah.
think it would make much, but
Yeah, but we could try.
still, it seems it would be cleaner that way to me.
Yeah, so this is not a standard in econ usually, but yeah, I get your point that yes,
Yeah.
we could try that. Yeah.
But the interpretation of these numbers is minus 1.6 means 1.6 percentage points.
Yes,
Of-
decrease
of-
in mortality.
So from 13 per 100 to 11 and a bit per 100, something like that.
Yes, something like that.
Okay.
Yeah, yeah, exactly. Okay, so this is for under 5 mortality, and this is if we pool the last 2 time periods, and basically it shows you that there is a significant about 60% decrease in percentage points decrease. This is when we look at this by birth order. So here previously we were looking at all second and higher parity children. Now we split them by birth order, and what you see is that most of this effect is coming from second children, right? So in India, average fertility is about 2.83, something like that. So it's not surprising. So as you look at the sample size, also this keeps going down. But it's and also parents prefer to have. So if you're looking at families that have 5 children, they are just somehow very different families, right? So most of this, it's not surprising that the effect is basically coming from second children. So now, why is it that we see this decrease in excess female mortality, right? So proximate determinants of them could be one, that parents are investing more in these girls, or investing, the decrease is less as compared to before, or maybe there's that sun-biased fertility stopping tool story, right? So here we first look at postnatal health investment. So now we use data from the Rural Economic and Demographic Survey that I discussed earlier. So we look at 3 different things. So they don't have data on everything. And remember, this is a data that comes from 1999. So our post period is limited. It does not go up till 2005 like before. And again, this is looking at health investments in surviving children, right? So children who were put in very little investments and who actually died are not even in this data set, right? So these are the relative survivors. So for this sample, what we looked at is how many months a child is breastfed. So there's previous evidence that Indian parents actually withhold breastfeeding for girls sooner because of the belief that when you're breastfeeding, you're not as likely to conceive, right? So if people have shown that if parents do not have a boy, they're much less likely to breastfeed their girl than if they had a boy, right? So we wanted to look at months breastfeeding, whether the child has received at least 1 vaccination, and how much was spent on his or her health when the child was sick. So again, this is conditional on being sick. So if daughters are sick more often because they don't receive as much care, so it's complicated. But what you see here is that before ultrasound technology was available, girls in firstborn girl families, relative to firstborn boy families, received fewer months of breastfeeding, right? They were less likely to receive vaccination, and there was also somewhat lower expenditure on their illness. Okay? After ultrasound became available, you see that, so this is positive, and we lose significance here, but basically it's positive in the sense that now you're getting more months of breastfeeding. You're also more likely to receive at least 1 vaccine, and not every child anyway receives all vaccines in India, and you're also somewhat, there's again positive but not significant, some increase in health expenditure, right? So this suggests that parents are increasing investment in girls relative to boys in firstborn girl families relative to firstborn boy families after ultrasound relative to before. Okay, so what we can do is, so using estimates from other papers which show what is the contribution of say 1 extra month of breastfeeding to mortality, what is the contribution of immunization to mortality. Given our estimates, we can do some back of the envelope calculations to see how much of this can explain the decrease in mortality we saw previously. And what we get is that about 27 to 31% of the effect we see before comes from this, right? So clearly this is not the only source of that variation. Yeah.
So I have a question regarding the second line here. Maybe I don't understand properly, but these coefficients 4.7, 3.9, do they mean that girls are breastfed longer?
Relative to boys, relative to so that gender gap, relative to firstborn boy families. Yeah.
So why would girls be breastfed longer than boys.
So they're not breastfed longer. So think of it as, let's say the earlier the difference was girls were breastfed 10 months less, now they're breastfed 5 months less. So
Okay.
that difference goes up basically.
Okay.
Yeah. So that's why this is positive, but doesn't have to mean that
It's all
on
the
average,
same
yeah.
model. Yeah, okay, thanks.
Okay. So and again, this could be because we don't have parents do a lot of other investments in children, and this is simply looking at 3 things, right? So, but even these 3, if these estimates tell us something which is true, then it at least explains a third of the effect we see. Okay. So the second thing we looked at is fertility. So there is evidence that parents practice unbiased stopping rules, and there is evidence that that contributes to gender gaps in outcomes because girls are born in larger families. But if you can now practice sex-selective abortions, girls do not have to be born in larger families, right? So what you should see is that if earlier a girl in a firstborn girl family was born in a larger family, now she should not be born in a larger family, right? So that's what we test for here. So, but before that, one thing to keep in mind is that just because there is access to sex-selective abortion doesn't mean fertility has to go down. Right, so it can go down because now there's basically conditional on being pregnant, you have fewer births. But at the same time, knowing that if you became pregnant, you could have an abortion may increase conception rates. Right, so that on average, we don't know whether which of these effects is dominant. Obviously, my prior is I think it will decrease because there are just way more abortions than the increase in conception. But we don't have any data on conception, so we can't say that. We simply look at the actual births that take place. Okay? So we checked whether fertility decreased in the post-ultrasound period first, and whether that decrease was concentrated in families that were predisposed to sex-selective abortions, which in our case is firstborn girl families. Okay? So we do this in 2 ways. One is we utilize our mother year panel. So what we know is for each year that mother is in our data. So the mother enters our data when she gets married. So premarital fertility in India is pretty small. So she becomes at risk of pregnancy when she gets married, and then you observe her till she is surveyed, and then each of those years in between. So for each of those years, we know whether she gave a birth or not, and if she gave a birth, whether it was a boy or a girl, right? So using this panel data, what we do is we compare the likelihood that a mother gives birth in year T in state S of age A and so on. So this is a hazard estimation, and we compare this likelihood of birth for mothers who in years after ultrasound became available versus before, and dependent on whether their first child is a boy or a girl, right? So we look at the likelihood of marginal fertility for a woman who has a boy, first boy versus a first girl, and before and after ultrasound. Okay?
So this is not whether you have another child, it's how many months?
It's simply in that year, do you have a child or not? Do you give birth in year T or not?
So just,
It's like each year of your fertility history,
Mhm.
do you give birth in that year or not? Dependent on whether you all have your first child is a boy or a girl, and whether I'm observing you after or before ultrasound. Okay? So
But if we change birth intervals from, if the Pare progression is the same, but we change birth intervals, that will show up in this regression.
yes. And then I'm going to also do a different regression where instead of this likelihood, I'm just looking at the total number of children. So that will sort of get away with that. Yeah.
And the idea is that if I know I don't have to have a girl, I can risk getting pregnant.
Yeah, so that could be, plus if I may have an abortion if I get pregnant, right? So both, it's the net effect of both those things. Right? Okay, so what do we see here? So, sorry, this is a bit small. I don't know if you can see it. Let me expand it a little bit. Okay, so it's the same system as before. So this is telling you the likelihood or the hazard of birth to a mother before ultrasound when she has a firstborn girl, and what you should see is that she is more likely to give birth relative to a firstborn boy family, right? And then after ultrasound became available, the hazard of birth significantly decreases for these mothers, right? So this sort of tells us they were likely to follow some biased stopping rules because fertility is higher in families where the first child is a girl, but after ultrasound that goes down. And this is true even if we control for the mother's self-reported ideal sex ratio and ideal number of children. So of course we don't want to use these everywhere because there's a lot of exposed rationalization. We don't know what these really tell us. This mother may be just misreporting it. But even if we control for that, we see that it still is true, right? And in fact, these coefficients themselves are interesting because this is telling you if a mother wants more children, she has more children, right? Which makes sense. And this is saying if she wants a greater sex ratio, which means more boys per girl, she has more children, right? So this explains sort of why we see this pattern here. Why mothers with a firstborn girl are more likely to have children before ultrasound? Because they are trying for a boy.
So this is just the same problem I'm having with the differences, but let's say that post 1 and post 2 were not ultrasound, but they were increased availability of contraception.
Yeah.
Then I guess my intuition is that we'd see the same results, but there's something about your identification that is picking up on the sex-selective nature of it. It's telling
So
us
if
that
it
this
is
is a
just-
sex-selective effect.
Yeah, because the contraception should not vary by whether your first child is a boy or a girl, right? So we shouldn't see this difference by firstborn girl. That's the point. Yeah.
Just so, because I think I guess so, but what if like economic liberalization meant more women entering the workforce and so they were more, potentially more,
Exactly. So, but as long as that doesn't vary by whether your first child is a boy or a
Yeah.
girl, we're fine.
right?
Right? Because we're controlling for all these other things that do not vary by the first child's sex. Yeah. So mothers are more likely to work, they're getting more educated, everybody wants fewer children, but none of that should be correlated with whether your first child is a boy or a girl. Right? Because that we've shown is random. There is
Right.
no correlation between mother's education status and whether her first child is a boy or a girl.
Right.
And we're only looking at that source of relation.
But you find the net effect of the post 2 period is that people actually have fewer births.
People have fewer births, yeah. If people who have a first girl have fewer births relative to people who had a firstborn before, right? So it's a difference in difference.
Yeah.
So maybe firstborn boy children before ultrasound also had fewer births, right? These people had more births relative to firstborn boy families. It's just that now there is a decrease in that.
But the net, it's bigger. It's a bigger effect than.
So again, we shouldn't just add up and so it's definitely large. So what we can do is have just one post and then compare it with this. So it's not larger than that 155. It's basically coming closer. It's not like
Got it.
surpassing it. Yeah. Okay. So we do this in a different way. So instead of looking at the likelihood of birth in each year of a mother's fertility history, we look at the total number of children she has when we survey her. So we look at mothers who were surveyed after these rounds and before these rounds, before ultrasound, and we compare the total number of births at the time of survey relative, and how does that vary by what their first child sex is, right? And so what we see is the same pattern. Mothers whose first child is a girl reported having more children before ultrasound than mothers who had a first boy, and that difference decreased as we went after ultrasound, right? So from a firstborn girl mother had on average 0.155 more children than a firstborn boy mother, and that decreased here after ultrasound. Yeah. Okay. Right? And again, so if parents are having fewer children and they are aborting children that they do not want, then we should see parents moving closer to their desired fertility. Right? So what we see is whether the difference between actual and desired fertility is also narrowing. And in last column, that's what we see. So excess fertility, there was excess fertility in firstborn girl families before because they couldn't abort these unwanted girls, and then we see that actually decreases after ultrasound. Okay. All right. So I'm not going to go into this, slightly complicated, but we know there is a lot of variation in heterogeneity in which sort of SES groups in India commit sex selection and so on, and so we try to look at these patterns. But overall, what we find is that, yeah. So the interesting thing is we want to see. So we are showing that there is a decrease in gender gaps in mortality in firstborn girl families because now these people can abort these girls before. So we wanted to compare how many girls are being aborted versus how many girls are actually going to now survive because of this, because they're born in families who want them, right? And so doing this calculation basically tells us that about 90,000 excess under 5 female deaths were averted each year because parents had access to ultrasound technology. But if you compare that with the number of girls that actually went missing, or these are known as missing girls, because of this, that's much larger, right? So the extent of sex-selective abortion is actually much larger than the benefits of that in terms of postnatal gender gap decline. But at the same time, the point of the paper is sort of that there is this gap, right? So we may care a lot about this missing girls, but there's also this unintended positive effect because these girls would have been treated much worse if they were actually born. Right? And so that's sort of the main policy implication of the paper. And why is this important? This is important because if you look at excess female mortality in India, it's actually quite high, and it's much higher in firstborn girl families than firstborn boy families. So typically parents don't distinguish between these two groups, and then that sort of underestimates how much excess female mortality there is. So given that this paper is sort of the first that shows that there is this benefit, and why might we care? Because there's a lot of research on what the potential negative consequences of high sex ratios are in terms of crime, in terms of how it impacts marriage market balances, whether parents have access to old age support, and so on. And this paper sort of also contributes to that literature. The other thing is, even though we are comparing this 90,000 number with the sex selection number, we should also keep in mind that these girls are going to grow up and have children of their own. And we know that healthier mothers tend to have healthier children, and more educated mothers tend to have more higher quality children. So if that's the case, if we were to actually translate this into the net benefit, that may be even higher in some sense, right? Because these better end up, because they're getting more breastfeeding, they're getting more immunization. We don't yet have results on education because we don't have enough data for that. But if these girls are actually going to do much better, then their children are also going to benefit, right? So in that sense, the benefit is also going to be higher. Fertility decreases. So if we think of mothers are also in some. So if this would depend on whether the cost to their health of repeated sex-selective abortion is higher than the benefits to them of not having to have repeated childbearing, right? So who is to say, so a mother who was continuing to have children when she had son bias stopping rules is now better or worse off, right? So that sort of calculation is also complicated. But what we see is that these women are less likely to have children. So to the extent that mothers bear children and then have to take care of them, now that burden is decreased because they don't have excess fertility, right? So the paper sort of, we don't take a stand on which of this is bigger, which of this is smaller, but the point is that this is there, right? So it should be taken into account. And yeah, so I'll stop here basically. There's a lot more in the paper in case you're interested. Yes, Ryan.
I have one comment and a couple questions. The comment is you implied at the very beginning that there were health impacts from multiple abortions, and there's no medical evidence of that. So I just wanted to clear it up in case
No,
people took that as.
no, I'm sure there is, yeah.
No, I have two questions. One, you mentioned there might be some evidence of decreasing son preference over time. I would love for you to tell about that. But wait, I gotta do my second one first, and then you can take over. I would love to see this analysis flip to look at excess female mortality in boy-first families to say, is there actually, can we eliminate discrimination when women are actually able to choose whether to have a girl?
Yeah, so that's very interesting. So we should do that. What we did was, so we didn't do that, looking at just first-born boy families and excess female mortality in that, but we looked at how boys did in these first-girl families, right? So because if you're going to have fewer children, girls, yes, benefit, but boys may actually also benefit because they don't have extra sisters.
Yeah.
So we do see that boys actually do benefit a bit relative to what they were before. So being born in a first-born girl family was also worse for the boy because he had to share resources with all his sisters. So we do see some impact there. But yeah, your question is different, and we should definitely.
It would be beautiful if you would do that, and you must have the infrastructure all set up.
Yes, we can do that. We can do that. In terms of son preference going up or down, it's hard to say because the only measure we have is this self-reported son preference. So you do see self-reported son preferences going down, but at the same time you see sex ratios going up, right? So is it the case that some people say it's because now desired fertility is going down, that's the reason why you see the sex ratio going up, even though parents' inherent desire for sons is actually lower, but it's still there. You want to have one boy. So, yeah. Yes, Josh.
So I found the basic story convincing. In other words, that if people are not having children that they don't want, that's probably good for the children if they do have. That sounds. But the interpretation that you have at the end seems to me would also apply, more or less, just to simple fertility decline. So increased availability of mechanisms for fertility control would help girls and help boys enormously, would help the mothers enormously. So I agree with your identified effect, but it seems to me that in the context of the things you're talking about, the fertility decline is in orders of magnitude more important than the sex-selective
but you have
changes.
to keep in mind that in India, fertility is very strongly correlated with son preference, right? So fertility decline, it has a huge component, which is the son preference. So it is decreasing, but it's decreasing in a different way. So the dynamics of it and and what is going on inside it is very different, right? right? So here we are saying that fertility, having fewer children is better, but what we are also saying is that fertility decreases less for families that had a firstborn girl before, and now it decreases more because they can use this source of contraception in some way or birth control, right? So we're showing you the same thing, but just telling you what goes on inside
So
that black box.
what fraction of the fertility decline do you think is due to the availability of this
Yeah,
technology?
we should try to do that. We haven't done that because
But you argue it's substantial.
it is substantial. Yeah.
My-
And in fact, there's this Seema Jayachandran's paper. She actually tries to do this. Probably she has this number for you. She shows that the sex ratio increase, a large part of it is driven by fertility decline. So they're jointly determined, basically.
I had a second question. Is there a part of India where there's no sun preference that you could kind of run an analysis on and show us that you don't get any of the time effects in that area?
So it's hard to know because these things, on average, yes, South India has less, whatever. But again, it's very hard to know because now what you see is, sorry, Northeast probably, yeah, because Northeast has many matrilineal societies, so it could be that we could look at those as a sort of.
But what she wants is a decrease in excess female mortality, and it wouldn't be the
No, what he's
same
saying
in
is that-
places where there wasn't
So
female.
what he's saying that you shouldn't find this there because there
Oh, I
was
see.
no excess female mortality to begin with. Yeah, so we could try to just focus on that region and see. Yes.
Have you tried any estimates where you use direct measures of ultrasound
We
use
have.
in a geographic area?
We have. So what we do is like when using the same variable that I use for my figures,
Yeah.
mothers reported use of ultrasound during pregnancy for actual children who were born. We try to do that. So we replace the post with that variable. And we see similar effects, but the power is not very high because those things do not, there's just not too many mothers who report these things, but we
Yeah.
see similar patterns there.
Suppose you used averages for a whole area.
So we do,
rather-
state year averages, yeah.
That's what you are using.
Yeah, that's
Yeah.
what we use.
It's just it's a noisy measure.
It's very
given
noisy,
your
it's
source of data.
underreported. It's only measured for children who actually were born, right? So it's a very different sort of, it's not telling us who was aborted.
Yeah.
We're simply relying on the fact that that's correlated with
But
use
is
of
there
ultrasound
industry
reports.
measures on
No.
usage
No.
of ultrasound
Yeah.
machines or availability or
It's
something
very
like
hard because a lot of this happens in the black market given that it's illegal to use it. So what you'll see is that in villages there'll be a truck that will come and with an
Yeah.
ultrasound machine. So
Sure.
those things are not really
Yeah.
recorded.
I mean, that certainly that approach has all the problems that Dennis was suggesting, and that
Yeah.
you,
There's a group at Oxford that's working on estimating this with Google search data.
Oh, okay. That's
Yeah.
interesting. Yeah, yeah. That would be very nice.
Check it out.
Given that one of my co-authors is there, I can
Yeah,
ask him
right.
to. Yeah.
I can give you.
Okay. Thank you.
Wonderful. Well, thank you so much.
Thank you for all your comments.